Good morning all. Now we will discuss about inductance L. Okay, the property of inductor which doesn't allow sudden change in current. Okay, the major property of inductor, it doesn't allow sudden change in current. Okay, see here it is the symbol of inductor. Okay, this coil is having inductance L. Okay, the units for inductance will be Henry or H. Okay, the voltage across the inductor formula is V suffix L is equals to L into di by dt. Okay, next, the inductor is a energy storage element. Okay, inductor, it stores the energy in the form of electromagnetic field. Okay, now we will discuss about the factors affecting inductance. Okay, the inductance value depends upon the shape of the core. Okay, next one, it directly proportional to the square of number of turns. Okay, that means if L is directly proportional to n square, okay, that means the inductance value increases. If number of turns increase, more number of turns are increases, the inductance value is also increases. Okay, next, it is inversely proportional to the inductance of the magnetic path, or are inversely proportional to the reluctance. S is nothing but reluctance. Okay, from those two equations, L is directly proportional to n square by S, where S is reluctance. Okay, where n is number of turns. Okay, that is about inductance L. Okay, next, coming to capacitance C. Okay, capacitance C, which doesn't allow sudden change in voltage. Okay, which is denoted by C. Okay, here it is the symbol of capacitor C. Okay, the charging current in capacitor is given by IC is equals to C into dV by dt. Here capacitor is also a energy storage device which stores the energy in the form of electrostatic field. Okay, the stored energy is directly proportional to the voltage or potential difference, that is Q is directly proportional to V. Q is equals to C into V. C is equals to Q by V. Units for capacitance will be farads. Okay, now we are having clear understanding about a resistor and inductor and capacitor, right? Okay, now see here. Okay, capacitor and inductor are the energy storage elements. What about resistor? Resistor is not a energy storage element. Resistor is a heating element and heating element. That means always it will consumes the energy. Okay, whereas inductor and capacitor are the energy storage elements. That means it will stores the energy certain moment and again it will supply the energy. For example, let us take a fan. Okay, if you switch on the fan, what happen? Fan is having a capacitor, right? The purpose of capacitor, it doesn't allow sudden change in voltage, right? If you at the moment if you switch on the fan, the speed of the fan will be slowly increases. Why? Because the capacitor doesn't allow sudden change in voltage from 0 to 230 volts. That means the voltage will slowly build up from 0 to 230 volts. Okay, for that period fan is slowly moved, that the moment of fan is slowly increases. Once it reaches 230 volts, the speed of the fan is constant. Similar way, if you switch off the fan also, the voltage will not comes to 0 at a certain moment, right? That means the voltage will comes from 230 to 0 slowly. It will take around 10 or 15 seconds, right? In that period it will slowly comes to the normal speed and switch comes to 0 position. Okay, that is about the application of capacitor. Okay, now see here, now we have a clear idea about what is mean by voltage, what is mean by current, what is mean by power, what is mean by energy, and what is mean by resistor, what is mean by inductor, and what is mean by capacitor, right? But already we know that in houses we are using so many electrical devices, right? But we are getting electricity bill in number of units, right? Then how to calculate that electricity bill? Okay, now for understanding this point, already we know energy, right? Energy is nothing but power into time, right? Okay, that is nothing but units per power will be watts, units per time will be seconds, right? If I write in terms of kilowatts, kilowatt, in terms of hours, kilowatt hour, right? That means 1 kilowatt hour is equals to 1 unit. This is the way of conversion. Okay, 1 kilowatt hour is equals to 1 unit of electricity bill. Okay, that means for 1 unit how much charge you need to pay, that much amount of bill. For example, in your home, for example, if you are using 4 fans, 4 tubes, okay, the rating of each fan will be 200 watts, the rating of each tube will be 60 watts, right? Now see here, 200 watts of rating of each fan. Then for 4 fans, 4 into 200, 800 watts. This is 4 into 60, 240 watts, right? Next see here, this is the wattage. For example, I use these 4 fans for daily 8 hours. Same way tubes used for daily 10 hours. Then power into time is nothing but energy, right? 800 into 8, 6400 watt hour. Here it is watt, this is hours. Here 240 into 10, 2400 watt hour. That means 64 plus 24, 8800 watt hour. That means convert into kilowatt hour, 8.8 kilowatt hour. Okay, but already we know that 8.81 kilowatt hour is nothing but 1 unit, right? That means 8.8 units consumed per a day. But per a month, assume an average every month is having 30 days. 8.8 into 30. Okay, you will get 0. That is 88 into 3. Okay. That means 264 units. Okay. That means in this way you will get the electricity bill. That means for example, cost per unit, assume for 264 units cost per unit will be 5 rupees, assume. Okay, then 264 into 5, 5 4 the 20, 0, 32. That means you will get 1320 rupees as a electricity bill. Okay, in this way only you will get the electricity bill. Okay, that is about basics of electrical and electronics engineering. That means here you are having a clear idea about some basic definitions and basics of resistor, inductor and capacitor. Okay, remaining we will see in next class.